Hello guys, this is a quick video to explain this beautiful diagram on the screen. This diagram on the screen represents a 4x1 multiplexer implemented using logic gates. And then a question is, what is a multiplexer? A multiplexer is a digital switch that has multiple inputs and then a single output. So basically the function of the multiplexer is actually to select one input from many inputs and sends it to one output. So to cut this short, I'm about to show you a breakdown of how the diagram works, how the 4x1 multiplexer works. So to start with, the diagram contains gates, different types of gates, which are named NOT gates, AND gates, and then OR gates. So I'm about to show you how to determine which gate is a NOT gate, an AND gate, or OR gate. So the selected one, which is the S0 and S1, these are NOT gates, which actually determine which inputs that are going to be selected. And also, this diagram has a total of 4 AND gates. The selected one. These are 4 AND gates. And also, it has an OR gate at this end, the selected one. And then this OR gate it serves as the output. It gathers all the signals from the AND gates, the four AND gates. But since only one is going to be selected, it only outputs one AND gate. So I'm about to explain briefly how this multiplexer works. So using this simple truth table with an example, when S0, let me start with the S0 NOT gate and then the S1 NOT gate. This S0 and then S1, they are 2-bit code, and then they serve as control lines that decide which inputs get selected. So this simply means when you are using a truth table like this, the values of the S0 and then the S1, they help to decide which inputs. And the inputs here I'm talking about is this 4 AND gates that are assigned to I1, I2, I0, I1, I2, and I3. So basically, let me give you a quick example. Let's taking S0, which has a value of 0, and then S1, which has a value of 1. Automatically, its selected inputs becomes I1, and then I1 is actually here, this highlighted one. So taking S0's value as 0 and then S1's value as 1, according to the truth table, I1 automatically gets picked as the active input. So it ignores, since I1 gets picked, the remaining AND gates, which is the I0, I2, and I3, are being ignored. So I1 becomes active, and then finally it's being sent to the OR gates over here to produce a final output. This operation applies to the other inputs. Also, taking an example from this side, using S0, which has an input of 1, and then using S1, which has an input value of 1. Automatically, the selected input is 3. I repeat, taking the value of S0, which is 1, and the value of S1, which is 1, automatically the I3, which is the selected input, becomes active. So finally, I3, this one, it becomes active. So when it becomes active in this way, the other AND gates are being ignored because the multiplexer only selects one input from many inputs, and then it's being sent to the OR gates for a final output. So this is the end of my video. Thanks for your patience. Thank you.